back to another exciting episode of This Is My Tele. No, that's not really what it's called. This is the Telecaster student build. Why does a student build? I'm going to say it every single time because I know some people are seeing this series for the first time and you got to go back and look at the other 10. But this is episode 11 of a Telecaster that I'm building on video for the students that I am teaching at a local college in their luthier program. We're up to number 11, and at this point we're ready to start making Pickguard for this particular Telecaster, and we're going to mount the neck. So we've got two main things that we want to accomplish, and these are the two last things that I can think of that need to be done prior to us dry fitting the hardware to make sure everything is in a perfect alignment. And that is the last thing that I'm going to do prior to beginning the finishing process of this guitar. So we're really kind of coming down to the home stretch, and I hope everybody is enjoying this series. I appreciate a lot of the positive comments, and hopefully my students have enjoyed it and will enjoy it into the future as they go off to try to build their own guitars and things like that, that they can refer back to this if they ever need to. All of the Maximum custom guitars that I build carry a signature name. That name is normally a female name, just because it just seems right. And I haven't named the Strat or Telecaster style builds, and honestly I just don't build a lot of copy guitars, so it's only because of this class and the requirements that I put on the class that I'm doing this. But I did the very first electric guitar that I ever built, I built for my daughter, and there's another story behind that I can share maybe a later time, but I named it after her, Shelby, and it was a Telecaster, and I named it Shelby T because it was pretty traditional in a Telecaster pickup combination. So because I'm using the Charlie Christian pickups in this, I'm thinking about keeping the Shelby name attached to my Telecaster design and calling that the Maximum Guitar Works Shelby series. And I'm thinking about calling this the Shelby CC for the Charlie Christian pickup combination. What do you think? Does that make sense? I like it. I think my daughter would like it, so I think it's a win-win. So I think that's probably what I'm going to do with this. The Strat, I'm not sure. I could name it after my other daughter, Stephanie. They both begin with an S. Not only Shelby and Stephanie, but Stratocaster and Stephanie. So maybe I name that after my other daughter. Who knows? And that's what makes life so interesting, does it not? Let's get right into the Pickguard. The question was asked for these cool Charlie Christian Lawler pickups. I had it done with a white pearlite cover on the top. I just think it's pretty cool. So the question was, what pickguard am I going to use? Because a white pearl would wash away, black pearl probably wouldn't look cool, and I forget all the other combinations. But what I'm doing is exactly the one that the gentleman who posted that comment said would get washed away, and that's a white pearloid pickguard. And I actually want the pickups to kind of disappear a little bit in that pickguard because I just think it's a cool look when they kind of vanish a little bit. Now that we know that the bridge pickup with the pearloid cover is going into that chrome Texas Toast Tele bridge like that, certainly that one won't be washed away. So I think we'll be pretty good with this design. But the cool thing about pickguards are, if you don't like it, you just make another one, okay? And you try different variations. I'm not a huge fan of the tortoise, but certain color combinations, it really works. So I guess we'll just see how it turns out. I've got enough pickguard material to make two, but I'll only need half of this for this time. So how are we going to do this? The overall concept of creating a pickguard is I'm going to use a template, and I'm going to use a template to actually rough cut with a bandsaw right around the template, and then come back and take it to a flush trim router bit in order to get it flush. And then I'm going to use a bevel cutting bit to actually chamfer that edge. Okay, and then I'm going to drill the holes, and the holes are already set up in here, so I will just drill the holes based upon this template when the template is still in place. So it's a pretty simple concept. The tricky part is, how do you create the template? Well, you could create the template from an existing pickguard that you have and just trace it and either cut it out manually and take it to an oscillating drum sander and kind of sand up to those points and then get it right where you need to be, either a new pickguard or a template for a pickguard. With the Pearloid pickguard, it's not hard to figure out what is top and what is bottom. But I'll tell you, if you have a white pickguard that's a 3-ply or what have you, you have to make sure you recognize which is face up and which is face down in order to mount your template to the correct side. The face up side, in this case, will have the Pearloid, but in a white pickguard base, it normally is the only side that has a protective cover on it. It's the side that's highly polished, where the other side will not be. It's the side, if there's multiple layers in there, that probably the top white layer is thinner than the bottom white layer, because when we create that bevel, you want to bring out that accent of those layers in the bevel. In fact, that's the only reason you bevel. If you have a solid color pickguard, you don't even need to bevel it. Okay, the bevel is only for the cosmetic reasons of seeing the multiple layers. All right, and it adds a touch of elegance. I like it in most cases. But sometimes a good solid. In fact, the second Strat that I'm making at the school is going to be a walnut drop top over alder that I think is going to be really cool with a maple one-piece neck with black walnut dots and truss rod cover in the back. And in that particular one, I'm going to use a flat black solid pickguard material. Therefore, there will be no bevel associated with that. And I think that one will look pretty cool in that guitar. But anyway, let's get this process going. The concept, in order to get everything done with one mounting of the template, is you have to mount the face of the template. Okay, so the face of the template right here to the back side of the pickguard material, just like that. Now, the reason that we do that is we can now turn it this way and use a top bearing bit in the router table, and we can flush cut everything. But then we can in turn put the bevel cutting bit on the router table and have the template as a guide, and therefore the bevel is being cut away from the top of the surface, which is where you want it. That's why the placement of the pickguard, this is probably too much explanation, but I've seen it get done backwards many times, is the placement of the pickguard is very critical based upon the sequence of operations that need to be done to create the pickguard. Very simple process if you get past that first point. This isn't a high stress procedure, so I really try to minimize the amount of double stick that I'm using here. All right, we've got 5 pieces of tape on that, and we're just going to place it on the pickguard material. I try to adjust it so I use it as efficiently as possible, but that looks fine. So now that that is stuck on there, we are ready for the process. I'm going to cut this out in the bandsaw. I'm not going to show that. Honestly, my small bladed bandsaw is in another area of my shop, and I'm not going to drag the camera over there. So I'm just going to cut this out, and then we'll be back to show you what we're going to do for the routing process. Now, what I try to do is get that about 2 millimeters from the edge of the template. 3 is okay. 4, it'll be okay too. But the phrase of the day when cutting on the bandsaw with your template still attached to the pickguard is, "Don't cut my template, bro." Yeah. So you got to be careful. I'd rather you shy a little bit away from the template than get so close that you nick the template. all right, or trace the line first on there, then cut it out, then double stick it into place. That would be even safer. So I just drilled with a Forstner bit a hole in the center of the pickup hole, and that will make it easy for me to flush cut that all the way out too. Okay, we've got a 1/4 inch flush trim router bit. It's got a double bearing at the top. Pretty nice bit. It's actually a single flute, which is better for cutting plastics. It doesn't heat up and cause the plastic to gum up like a 2 or more flute would. And we've got that bearing set up so it's going to hit the acrylic, and therefore it will just only go up to the edge of the template, and then it will stop. The 1/4 inch is ideal because some of these radii are so tight that really a 1/4 inch is the best bit for that. Anything larger wouldn't get you the right shape. Now I was a little concerned about in here the PDF diagrams that Lawler provides for the installation of the Charlie Christian pickups shows pretty sharp edges there. So obviously even a 1/4 inch bit isn't going to get those sharp edges. I can come through with a file and I can kind of square them up some. But I just tested the pickup itself, and it fits in there with even that little 1/8 inch radius taking place on that 1/4 inch router bit. So I may just be fine just to kind of leave it as is, and we'll see how it looks. If it looks funny, then not ha-ha funny, but like strange funny, then we'll fix it. All right, now we're ready to do our bevel cut. We do have a 45-degree bevel bit installed. And this is a pretty nice one. I actually got this one from WD Music, where I get my blank pickguard material most of the time. And it has a very short distance between the carbide blade and the bearing. Some of the bits that I get at my local sources have a little bit larger gap, and that doesn't really help me so much when I'm trying to do such a thin material like this. So anyway, that's what I've got, and I've got the height set up to just barely fall short of my acrylic template, and that should be all we need. So let's get going, eh? Now I didn't mention this before, but when you're doing pickguards, there's always areas that you do not want to bevel. In this particular case with the Telecaster, it's the end of the control plate where the bridge plate is going to go, where the neck is going to go, and where the pickup is. So those 4 areas you don't want to bevel, but everything else gets a bevel to it when it's a multi-ply material like this one. Okay, we're going to drill all the way through all of the pickguard holes with the 1/8 inch, although my Charlie Christian pickups are going to require smaller drill bits, so I'll do those separately. And for my custom holes, I'm again just going to use these 2. The smallest of those will be 1/4 inch, so I'll just do them both 1/4 and enlarge when needed with a step bit. The last procedure at the drill press is to countersink the holes that are the attachment holes. Don't need to do that with the pickup screw holes, nor do you do it with the pots that are going to be there. So the critical thing is to get the depth just right, because you don't want it too deep. So I like to kind of work up to it a little bit. I'll plant that drill bit and I'll give it about 1 turn and see what that gives me. I think that looks pretty good. It's just barely recessed. You can still feel the screw head above, but it's recessed just enough where it looks nice. So we'll just go ahead and do them all that way. This pickguard is basically done. Pickguard complete, or is it? I like to put foil in the back. Now typically you'll find foil maybe covering the pickup area on the back of pickguards. Sometimes you don't even find that. But I like to cover the whole thing. I mean, it's like, what can it hurt? Having a little extra grounding. The way that I do this is all of the cavities on the guitar will also be shielded, and I'll use copper shielding for those. And the reason why is because I like to ground wires to the shielding, and you can't solder the aluminum tape. You can solder the copper tape. So that's why I'll use copper in here. But for the back of the pickguard, aluminum is a little cheaper. So I will use that because it won't be soldered directly to, although there will be some copper that kind of comes up onto the surface, and then the aluminum will touch that based upon the pressure and the friction, and that will complete the grounding circuit so that everything goes to one point and we minimize the possibility of any noise. So that's the way that I like to do that. So I just roughly cut out with a pair of scissors for the back of this, and now I'm just going to peel it off and stick it on, and then we're going to trim it up. I ultimately want the shielding to be set back maybe 1/8 of an inch so that it's not visible in the edge of the pickguard. All right. Now that I've got everything identified, I'm just going to score about 1/8 inch back on all the edges. With this little X-Acto, I'll find all the holes, just kind of poke in the center and work that around, and just kind of knock all that material, that foil material, out of there. All right, so that's completely shielded, minus about 1/8 inch gap, plus or minus, around the outside perimeter. And that, to me, is the best course of action for pickguards. So that's what I did. All right, I just went into the drill press. It took all like 5 seconds, and I drilled 4 holes. Now, for me, I'm using 3/16 inch drill bit. And normally the process would be then to use these wood screws, and that would basically go down into the neck. Now, how do we align the neck? I will make sure that that is fully seated, and then I will get a clamp and drive that clamp somewhere right in the middle of all those holes. I'll make sure my fit is good, still tight, no gap under here, perfectly flush on the edge. And now here comes the tricky part. The 3/16 inch bit that I just used, we will slide down in there. I just spin it a little bit, and that'll give me a little point that I can follow. Now what we've got, very faint, but I can see four little indentations, and I'm going to accentuate those. And for the benefit of everybody in YouTube world, I just took a pencil and made a mark with inside there. And so now that you can probably see those, if I zoom in pretty close, you should be able to see those. Those are the locations for the holes we need to drill for the screws. Now, since we recessed the back of that heel area, these standard screws are going to be too long. So you can drive them in partly and get them to be nice and tight, not too tight, but nice and tight. Then you'll have to stop at a certain point. You'll have the threads already in there. You can cut these off with just a grinding wheel or whatever, and so that they only go just maybe 1/8 of an inch short of the fretboard. That way you have a little safety margin. Now, my personal technique for doing this is I don't use wood screws. I don't believe it's the best solution. So therefore, that's another area that I like to customize slightly. And what I do is I take a 1-inch, in this case, 8/32 stainless steel bolt, and I use a 8/32 stainless steel insert. These work really good into hardwood like you would have in a neck. So what I'm going to do is drill 4 holes in the neck to accommodate the stainless steel insert. Alright, so since this side is already radius, to drill holes perfectly perpendicular, I'm going to go back to my fancy schmancy jig that I actually built for the safety planer. But it'll be actually fine here. Instead of having a 3mm sloped wedge in there, I'm going to slide in there a little caul that will make this perfectly level. And now I can secure this in place and feel fairly confident that I've got very nice alignment going on here. The neat thing about this DVR Nova DVR drill press is I can set the stop. I can set 0 right there. I set the stop to 0.43, or was it 4? Yeah, 0.43 inches, which is approximately 11 millimeters. And now I get this lined up on the holes. A little center point will kind of help it center. And then I'll drill down nice and easy. Makes all these beeps. And I hit 0.43 and that drill bit stops. Perfect 7mm hole. There we go. Perfect holes. I like to get these slightly under the surface. So what I'm going to do first is countersink it just a little bit, not much. These Easy Lock stainless steel inserts are pretty nice. I'm not sure how easy they are, though. You can get a special tool to drive them in, but really, man, it just strips out so easy. So I basically have an 8/32 bolt with 2 nuts on it. And I'll thread that in. And then I'll use this driver because I can get a lot better torque on that bolt than I can these two little prongs that stick on this special tool that seem to always slip and want to strip out. So as long as I'm working it down nice and easy, they seem to go in straight okay. Pull it back out, and I've got those recessed 1 to 2 millimeters. And I move on to the next one. So that is the trickiest part. Sometimes it goes better than other times, but it's worth a little bit of the effort. You do not want to use power tools for trying to drive those in. This is the one time that some good old-fashioned hand tools does a much better job. So now we got all 4 of them in. You can kind of see there's our threaded inserts. Let's put the neck together. All right, so we got that sitting in there nice and tight. It's actually a very, very good fit, so it's easy to do that. And then we'll take a plate. And it looks like it's hitting a threaded insert with about 1/4 inch left to thread, so We could go a little bit longer on these. These are 1 inch. We could maybe go 1 1/4, and that would be fine. I'll start and try to thread them all first, and it looks like they're threading just fine. And then I'll go and get a couple of them tight. Like I said before, that's as tight as a set neck right there with those threaded inserts. Perfect fit right here, perfectly flush, no gap right here. That is absolutely perfect the way we want it to be. Man, I thought my game has been off on this episode for some reason, and I just figured out why. My Yeti hasn't been in the footage. What's up with that? My Maximum Guitar Works Yeti. I gotta have it right next to me. That's the secret of my mojo. All right, I don't have much mojo. Here's the thing. All right, we set out to accomplish 2 main things, and not very complex, but multiple steps to do those, and you have to really do things in the right order. So we learned about doing the pickguard. We learned about basically trimming it, then flush cutting it, then beveling it, then drilling holes, then countersinking the holes. All right, and we did all of that. Then we put the foil on the back for a little bit greater reduction of outside noise, like fluorescent lights and things like that cause a lot of noise, especially with single coil pickups. So we did all of that, and then we went through the process of actually bolting this neck on, a true bolt, not screw-on neck. It's not called a screw-on neck, it's called a bolt-on neck. And we did stainless steel inserts with stainless steel bolts, and we literally bolted that bad boy on. And that is a strong joint. Now we've got the components kind of sitting in place right now, and this guitar is getting there. It's getting there fast. So I'm really looking forward to the next stage. The next episode, what we're going to do is we are going to actually get the hardware in position, at least 2 of the tuners, high E, low E, and we are going to make sure everything is in perfect lockdown, alignment position. Then we're going to start putting screws and screw holes in everywhere in order to solidify that position prior to going to finishing. Big steps coming ahead, but that's all we've got for episode number 11 of the Telecaster student build. If you got any questions, post comments. I'll try to get to them as soon as I can. Don't forget to subscribe and click that little bell icon so that you get notifications. But until next time, remember, no matter what you do, start with excellence. Alright, here's some top secret extended bonus coverage for those of you who stayed around long enough in this video. We're doing the Tele in this video, but I wanted to show you a little Strat deal. If you look on my Strat template, I've got a very large hole. That is 5/16 wide by 34.5 millimeters long. Okay, 5/16 because I'm using a 5/16 inch bushing, a 1/16 inch router bit, and that then is going to slip into that slot and only go so far and have no movement whatsoever back and forth. So it's going to create a slot that is 1/16 of an inch wide, and whatever the length is that I need for the standard blade switch of a Stratocaster. So this is how I accomplish this with very little pain and aggravation. Here we go. go back to the front, and there it is. There's our blade switch slot. Bonus coverage, only available here at Maximum Guitar Works Telecaster Build Episode 11.